Sure. Sure notes. All right. So, and when you were in physical science, you learned about electrons being arranged in these concentric circles like this. Remember that? Okay, we already been through that, where we put all the electrons on those circles, right? But electrons don't just exist in these primary energy levels, and that's what these spheres, these circles that represented spheres, that's what they represented. Within these spheres are sublevels and orbitals. Okay, so they're broken up. It's not just all the electrons in this energy level anywhere in here. They're actually separated into other regions. Now, the first energy level, this one right here, where we just have an S sublevel, if you remember your orbital notations, the first primary level just had an S sublevel, and the S sublevels only had one orbital. Turns out that orbital is the shape of this primary energy level, this spherical shape. Okay? By the time we get to the second primary energy level, we have S and P sublevels. So we have S orbitals and P orbitals, actually one S orbital.
That's in the third or second?
In the second. Okay? And then that continues on. Every subsequent level we come to, we've got S and P sublevels along with D's and F's sometimes. Okay? We're only going to be looking today at S's and P's. We're not going to try to figure out the three-dimensional arrangement of D or F orbitals, okay? Just S and P's, okay? So within this second primary energy level, there are P orbitals that look like two floating mushroom heads in space.
That's the big circle?
No, the big circle is your S. This is the primary energy level boundary. But it turns out your S sublevel corresponds exactly to that outer boundary. Okay? So your S sublevel has the same regional boundaries as that primary level. Okay? But within that primary energy level, there are also these cutout sections that make up the P sublevel. And the P sublevel has, remember, 3 orbitals. Remember 3 boxes when we're doing orbital notation? All right? And those orbitals look like double mushroom heads. Not one mushroom head, but 2 make up a single orbital. So if we could draw it something like this. Okay, that's kind of like a mushroom head sitting up there. Okay. It's, for Kenya and Carissa, it's almost like a half a basketball. Almost. Okay. All right. Now, that's just one p orbital. That's just one p orbital. Okay. How many p orbitals do we have? 3 of them. Okay. So there's a second p orbital, which has another set of mushroom heads over here. Okay, something like that. Huh? They are called nodes, that's right. Okay. Then there's a third p orbital that comes out, is floating up here above the paper, and that second node is behind it. Okay, which we can't really draw on a 2-dimensional sheet of paper, right? Which is what we're going to do with balloons. We're going to be looking at that with balloons. Now, let's take a look at just one of these p orbitals, okay? Here's a mushroom head. Okay. It sounds like a band, doesn't it? The mushroom heads. Okay. All right. So here's our mushroom heads. Okay. That's the actual shape of the p orbital. But that's a little bit hard to illustrate because I can't have mushroom heads sitting out in space like that. What I have to do is have a way to connect it all to kind of make some sense out of it. So what we're going to do is we're going to take 2 round balloons and we're going to put them together like that, tie them in the middle to make something that resembles at least our mushroom heads. So when we take our balloons, you're going to make one balloon here, okay, tie it there, do another balloon, tie it, and then tie them together. And then we'll draw a line, a dotted line around the center of the balloon, like that. And then the top half of those will represent the actual orbital. Okay? Now, these are arranged so I've got one that's up and down, one side to side, and one coming back and forth. Okay? If I were doing graphing on a Cartesian plane, what would I label this axis right here?
X.
The horizontal axis is x. What is the vertical axis? Y. Well, if I'm going to do this in 3 dimensions, so I'm not going to have a 2-dimensional graph now. No, I have a 3-dimensional graph. I'm going to have one graph line coming out toward me, okay? And the other part's going back behind the line like that. That might be z. So if this is x, and this is y, and this is z, okay? Then if we fit these balloons on these axes, then the 2 balloons I put on x would be px. Okay, so this is p. This would be the px set of balloons. Okay, so here's these would be p sub x. P sub x is what both of those nodes are. P sub x. Okay. Then the balloon that goes up here is going to be called what? Py. But it's just the top half. Remember both of those. Okay, that's py. Okay, and then I got a set of balloons coming out here on this big old axis sticking out in front, and the little one going behind. That's going to be what?
PZ.
PZ. See how complex this starts to get?
Easy peasy.
There you go. All right, so that becomes kind of complex, doesn't it? That's why we're going to do it in 3 dimensions to make a little more sense out of it, so our drawings are not too complex for us. Okay?
Our balloons are not all the same size.
They need to be the same size.
You heard it.
Same size balloons. Okay? All right. So here's step number 1. Step number 1 is to blow up one round balloon. And here's a little help for you, okay? Don't blow it up too big. Okay? Just make a nice round balloon.